right, here we go. This is Separate Ancestry Moments number 1. Human and chimpanzee Y chromosome dissimilarity destroys evolution. Now, this is going to be a series that essentially complements the Case for Separate Ancestry series. And so I've put out episode 1 of the Case for Separate Ancestry, titled A Literal Adam and Eve. And so that first episode was nearly 2 hours. And so if you're looking for all the details, a comprehensive breakdown in terms of what this moment number 1, is going to cover, please do check that out, because these moments are going to be a lot shorter. And this is also a Patreon exclusive series. And so for only $1 a month, minimum $1 a month, you can become a Standing for Truth Ministries patron. And that'll help us continue working ministry full-time and putting out full-time content. And so let's get right into it. A lot of people ask me, what is the best evidence for separate ancestry and a literal Adam and Eve? And I think one of the best answers is the fact that we've discovered our first parents, the first couple, Adam and Eve, in our genetics. For example, this right here is a Y chromosome family tree. And this family tree only represents a couple hundred generations max. The branches in this tree have mutations. So essentially, this is random mutations over time, in populations over time. And you can literally count up these mutations. We know which mutation led to each branch. And the length of the branches is very easy to explain in a biblical time scale. There are not thousands of mutations here. There are only a few hundred. And with a fast mutation rate in the Y chromosome, roughly 3 per generation, and low genetic variation overall in this DNA compartment, uniparentally inherited DNA compartment. And so the Y chromosome, we inherit from our fathers. And every single male Y chromosome on the planet is nearly identical and go back to one single common ancestor, specifically Y chromosome Noah, just 4,500 years ago. The genetic variation to explain in biblical time is trivial. And it's important to note that according to the evolutionary model, if we actually share a common ancestry with the great apes, they would say the chimpanzee is our closest cousin, and humans and chimpanzees essentially split from a common ancestor roughly 6 to 10 million years ago. Now, if this really were the case, we would have essentially split from a common ancestral population. And that common ancestral population would have a lot of genes floating around. That population would have a lot of genetic variation. And so this ancestral population that we would have hypothetically shared with the chimpanzees would have had a diversity of Y chromosomes, this uniparentally inherited DNA compartment. As that ancestral population diverged into different groups according to the evolutionary story, for example, humans going one way, chimpanzees going another. One specific group, let's say humans, could conceivably comprise individuals that are more different to each other than they are to a chimpanzee on the Y chromosome, but this is not the case. And yet, if evolution is true, it could have been. If humans and chimpanzees really did split from a common ancestral gene pool. What we actually see is one Y chromosome. And all male Y chromosomes go back to a single Y chromosomal ancestor. And the same thing is true for the mitochondrial DNA. In this mitochondrial phylogeny, we've got rapid growth from a center point, We have low variation, a fast mutation rate in the mitochondrial DNA compartment, which is inherited on the mother's side. So it's a uniparentally inherited DNA compartment, and women pass down their Y chromosome. It's a small piece of DNA that we can trace right back to one female ancestor in the not so distant past. And so what do we have? We have evidence for one man, Y chromosome Noah, that gave rise to all men on the planet. And we also have evidence for one female that gave rise to every single woman in the world, mitochondrial Eve. And the diversity in both DNA compartments tell us that these DNA compartments are young because there's only a few DNA differences separating any two people. In the mitochondrial DNA, the mean, the average, is between 20 and 25 separating any two people. And so to explain that amount of variation, in light of the fact that we have a high mutation rate, far higher than the evolutionary community has ever predicted, about 0.5 per generation in the mitochondrial DNA, even at 0.1 per generation, it's far too fast. And for the Y chromosome, roughly 3 per generation. And so to explain the genetic variation that we see in these DNA compartments for the evolutionists is very troublesome, almost impossible. But for the biblical model of ancestry, very easy. So as we move on here, as you can see, pedigree-based mutation rates, that's the empirical rate. That's basically where we can measure mutation rates in the present. You can take grandparents, parents, children, count up the DNA differences, and essentially get a mutation rate that, according to even the secular literature, estimates of the mutation rate with a non-phylogenetic approach, namely pedigree analysis, are reported to be approximately 10-fold higher than phylogenetically derived rates. And so with incredibly low variation in these DNA compartments, a fast mutation rate, we can actually account for plenty of purifying selection over time. Purifying selection being a mechanism that evolutionists oftentimes erroneously accuse biblical creationists of ignoring. No, we can account for more than enough purifying selection. And as a matter of fact, over time, your observed mutation rate eventually equals a fixation rate. And according to the biblical base model, we have a bottleneck right after the flood, where the earth essentially restarts with 8 people. At the Tower of Babel, a few hundred years later, you have another mini bottleneck where you have a fast mutation rate acting upon a small population that's rapidly growing. You're going to have rapid or accelerated fixation rates during that period of time before human beings spread out into all parts of the globe. And so again, it is extremely easy to explain worldwide diversity in these uniparentally inherited, non-recombining DNA compartments in just a few thousand years. Now, the last thing I want to mention before we move on to, for a few minutes, the Y chromosome dissimilarity between humans and chimpanzees, a fatal blow to the evolutionary model. Evolutionists will argue that since Africa has the most diversity and everything nests within Africa, Africans must be older than non-Africans. This is why they argue for an out of Africa event rather than an out of Babel. And so because all your haplogroups nest within your African group, they will say that Africans are older, and therefore refuting the out of Babel model, because they'll argue since there's more diversity in Africa, all your different groups nest within Africa, we must have come out of Africa and not out of the Middle East. But what they don't realize is that everything is going to nest within the epicenter from which we have all originated or dispersed from. And the epicenter of genetic diversity is right around the Middle East and Africa. Where we place the epicenter is based on several assumptions, many of them being unknowable for now. But realistically, all we need is higher mutation rates. We understand that the mutation rate is variable For example, have a look at the HVR haplogroup, the most common haplogroup in Europe. You'll notice differing size branches, all going back to a common ancestor. What this means is people living at the same time are picking up more mutations than their cousins. People living at the same time picking up more mutations in the same amount of time. This tells us that mutation rates are variable. And therefore, it becomes incredibly difficult to pick a root. The evolutionists want to pick a root somewhere on your African branch. But unfortunately, picking that root is based on many assumptions, such as a constant mutation rate, among other things. And so all we need is higher mutation rates in African lineages, selective sweeps where, let's say, there was a selective sweep across Eurasia that resulted in older lineages basically being wiped out, with older lineages in Africa remaining or surviving. And so that's what we're looking at today. Or Africa could have had a higher initial population size, where after Babel, people groups start spreading out, but you have waves and waves of people groups going into Africa. And so we have many of Noah's descendants that could have moved into Africa. And as a result, they would be bringing in lots of diversity into Africa to start off with. Okay, so let's move on here. And so as you can see here, hypermutation, a reality. 2 families had genetic drivers of germline hypermutation. This is today. This is empirical data. This is from the secular literature. This is 2022. With fathers carrying damaging genetic variation in DNA repair genes. And so early in human history, when the environment was harsh, when people were spreading out, when there was a lot of inbreeding, or in Africa, you have people groups living closer to the equator, you could have a lot more radiation, especially if it's after the flood. And so all of these many reasons could result in damage to important DNA repair genes. And what that would mean is more mutations are being passed on. And a mutation adds diversity because it's adding something that was not previously there. Now, it's not necessarily beneficial diversity. It's more likely to be negative variation. That type of variation you get on your brand new car when it comes to dings, dents, scratches, and eventual rust marks. And notice this, the environment can affect the mutation rate. In this case, paternal exposure to chemotherapeutic agents before conception was probably a key driver of hypermutation. Notice this, supporting exactly what I just said, environmental exposures in parents, such as ionizing radiation, can influence the number of mutations transmitted to offspring. And so when you're looking at these branches, the branches essentially reflect DNA differences, mutations, diversity. And so your larger branches, let's say the branches in Africa, having more diversity to the evolutionist means it's an older branch, it's an older population. When in fact, there's many factors that contribute to a longer branch. And so early on in human history, for all of these many reasons considered, like radiation, increased radiation levels, mutations to important DNA repair enzymes, or even the fact that after the flood, you have this drastic change in environment, which could have resulted in a faster mutation rate. But yet we have early biblical patriarchs after the flood living hundreds and hundreds and hundreds of years old. That means more mutations are going to accumulate over time in the somatic cell lines, of course, but also in the germ cell lines, which is where mutations are inherited from. And so more mutations in a generation being passed on, Ham, Shem, and Japheth, their kids, they could start off essentially with a whole bunch of new mutations that on a family tree could manifest in long branches, where the evolutionists would assume or interpret those long branches as being more time. In fact, it could just be a single generation, a couple generations. And so lots of factors, lots of assumptions go into their out of Africa model. And so Mutations in important DNA repair enzymes. Our findings imply that defects in DNA repair genes can increase germline mutation rates, in addition to their well-established impacts on somatic mutation rates. We also have a paper here where the overall mutation rate, notice how these papers are all from 2022. This is the most recent data out there. And so the overall point mutation rate is significantly higher in Africans than in Europeans in the specific region studied, the HBB region. So again, all of these factors considered, we have secular papers that are confirming that these things occur. This is empirical data, essentially refuting the basic assumptions that go behind the out of Africa model, or supporting the out of Africa model. Okay, so here we go. Right here, what we have is a depiction of your ape Y chromosomes, chimpanzee. The evolutionists would consider a human as a human ape, and then your chimpanzees, bonobos, gorillas, orangutans, for example, as non-human apes. So you'll notice here you have the chimpanzee Y chromosome. Now the Y chromosome should be relatively more stable because it's non-recombining. And so it's not autosomal DNA. It's nuclear DNA, but it's not autosomal DNA or diploid, where you have recombination every generation. The lining up of these chromosomes and the shuffling of genetic information, essentially, okay? But we know the Y chromosome mutates fast, a lot faster than the evolutionists ever predicted. And yet every single human Y chromosome, we have uniformity in human Y chromosomes. Very low variation, 99.99999% the same. But yet, between the chimpanzee, notice the human Y chromosome here and the chimpanzee Y chromosome, when you consider overall architecture, gene content, and size differences, the chimpanzee and human Y chromosomes are only about 35 to 40% the same. So wait a minute, between all humans, our Y chromosomes are 99.999% the same. But the evolutionists want to say that we're related to the chimpanzee, that the humans, you can see it here, the humans and the chimpanzee go back to a common ancestor. And yet the chimpanzee and human Y chromosome is only about 35 to 40% the same. It's half the size. Have a look at this, guys, half the size. And you'll notice that the chimpanzee and bonobo Y chromosome is relatively the same, especially when compared to the human Y chromosome. And yet this fits exactly with what we would say the separate ancestry model would predict. Because we, at least the separate ancestry model that I put forth, would say that you have humans with their being their own created kind. That's why we can trace all humans back to a Y chromosome Noah and a mitochondrial Eve. We'd say chimpanzees and bonobos go back to a created kind, an archetype. Gorilla being its own kind, and the orangutan being its own kind. And this is exactly what we see in the Y chromosome data. So you have people like Aaron Ra that are putting forth this phylogeny challenge to essentially show him created kinds. And right here, we're showing him at least 3 humans, chimpanzee, and bonobo created kind that go back to a common archetype or ancestor, gorilla and orangutan. And the Y chromosome, the uniparentally inherited DNA compartment known as the Y chromosome, demonstrates separate ancestry. And what's hilarious is the evolutionary community, they'll constantly look to nested hierarchical patterns in the biological world as evidence for common descent. And yet this is a break or an inconsistency in their nested hierarchy, because your human Y chromosome and the gorilla Y chromosome, you'll notice this, if you compare them, they are more similar to each other in overall gene content, architecture, size differences. We want to look at the entirety of the Y chromosome. The evolutionists, they go into their analysis with evolutionary-based assumptions. They're assuming that all of these organisms here, your humans, your chimpanzees, your bonobos, your gorillas, your orangutans, ultimately share relationship. And so when they go into interpreting or analyzing this data, they have that false assumption. They have that false starting point. And so that's why oftentimes you'll find them not comparing the entirety of the Y chromosome. They only want to compare, that which is similar. For example, an overall similarity in genetics, they'll ignore gaps, copy number variations, size differences, unalignable regions. No, we want to look at it all. And so when we look at it all, your human and gorilla Y are more similar than the human is to the chimpanzee and the gorilla is to the chimpanzee. And so this makes sense. Bonobo and chimpanzee Y chromosome, fairly similar. Human, way different than the chimpanzee and the bonobo. And yet the human and gorilla, which is a complete break in their nested hierarchy, are more similar than the chimpanzee and the bonobo. And yet they want to say that we share a more recent common ancestor with the chimpanzee. This is from their own secular literature right here. Dynamic evolution of great ape Y chromosomes. Despite a recent divergence of these species, their Y chromosomes differ enormously. Notice this. Enormously in size. So it's not even moderate. It's not even a moderate difference. No, this is an enormous difference in size and gene content. The chimpanzee Y is only half the size of the human Y. I've had so many evolutionists tell me, oh, that's not true. Show that to me. Prove that to me. And this is right from their own secular literature. It tells me that these evolutionists, especially the militant ones, they're not actually reading their own literature. They're not staying up to date on the data. And that's what we see with militant evolutionists like Aaron Ra, very out of date, out of touch with the literature and reality. The chimpanzee Y is only half the size of the human Y. The percentage of gene families shared by these two chromosomes that split roughly 6 million years ago, notice this, is similar to that shared by human and chicken autosomes, so biparentally inherited DNA, that split about 310 million years ago. It was a huge shock. It wasn't predicted. The evolutionists can't deal with this challenge. Puzzlingly, so they're confused, guys. They're confused. Of course they'd be confused because they're not going to question their basic premise. Their basic premise and starting point is that evolution happened. We're related to strawberries. And now they force fit all of that data into their model, even if it's inconsistent. Notice this. In terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y than to the chimpanzee Y, even though human and chimpanzee have a more recent common ancestor. The chimpanzee MSY, male-specific Y chromosome, essentially region of the Y chromosome, harbors twice as many massive palindromes as the human MSY. Yet it has lost large fractions of the MSY protein coding genes and gene families present in the last common ancestor. Remember, they assume common ancestry. And so they have to invoke major loss, major reorganization of the Y chromosome. Surprisingly, a big chunk of chimpanzee MSY sequence has no homologous alignable counterpart. Guys, more than 30% has no homology or alignable counterpart with the human Y. That means they have to invoke major loss. Notice this. What are the differences? There are two main classes of MSY sequences shared between the two species: ampliconic and X-degenerate. Humans also have X-transposed sequences, but the chimp does not. Guys, you couldn't ask for better evidence for separate ancestry. Now, what you get from the evolutionists is typically, I don't know, I got to look into it. Or from the more informed evolutionists, excuse after excuse, rescue device after rescue device. As a matter of fact, your more militant evolutionists that are desperate to believe that they're related to strawberries, whales, and essentially these great apes, they will invoke the same rescue devices, the untested hypotheses that are put forth as untested hypotheses in these papers. And so I see no critical thinking. I see no ability to actually look into this data in a way that suggests to me that they're looking at it objectively. The X-degenerate regions of chimp and man differ by a full 10%. This is huge, considering the 99% identical claim that we have heard parroted so often over the previous several decades. But this is only the beginning of the differences. To compare the ampliconic regions, they had to appeal to extensive rearrangement and rampant sequence gain and loss. In other words, a lot of storytelling, guys. A lot of storytelling. When you ask an evolutionist to explain the incredible dissimilarity of human and chimpanzee Y chromosomes, again, 30% the same if you consider overall architecture, gene content, size differences, and the fact that the human and gorilla Y are more similar than the human is to the chimpanzee or gorilla is to the chimpanzee. Sit back, relax, get a coffee because it's story time. And that's all you're going to get. You're not going to get anything empirical. You're going to get stories, untested hypotheses. And that's okay. They can have it, but it's not science. It's a story. It's a fairy tale. It's pseudoscience. To compare the ampliconic regions, they had to appeal to extensive rearrangement and rampant sequence gain and loss. I wanted to reiterate that fact. Half of the chimpanzee ampliconic sequence and 30% of the entire MSY has no counterpart in the human MSY and vice versa. Guys, there's massive differences here. Okay. And you could read through all this yourself. And so here's the last slide I want to cover. So what they're going to do and what they have done, for example, popular evolutionists on YouTube, Gutsit Gibbon, they'll say, well, there's sperm competition, polygamous relationships in chimpanzees. Chimpanzee Ys in general have, lots of variation within itself. Again, the Y chromosome mutates fast, even in humans. It's a rapidly changing Y chromosome. And yet we find no highly divergent Y chromosome people groups globally. And yet you'd expect, if the out of Africa and deep time evolution story was true, as people groups spread out after Africa and start independently accumulating their own mutations, and mutations are adding something that's not previously there, adding diversity, then you'd find highly divergent or more diverse Y chromosome people groups around the planet, but you don't. The Y chromosomes, regardless of where you look, are incredibly uniform. That is because the Y chromosome is young. That's the only way to explain a Y chromosome that is uniform, that has low variation worldwide, but also has a fast mutation rate, 3 mutations per generation. The only way to explain that, these are facts, these are data points, this is not a story. The only way to explain that is through the biblical model of ancestry that suggests all Y chromosomes go back to Y chromosome Noah just 4,500 years ago. And so they can invoke faster rates of gene conversion, polygamous relationships, sperm competition, whatever it is. But they're going to have more than just a story. They're going to have to apply mathematical models to try to demonstrate how a sequence can change extremely rapidly, including wholesale rearrangement of significant parts. Guys, they like to say we have a heat problem. They have a genetics problem. This one genetics-based problem alone precludes universal common ancestry from being true. I want to see more than a story. I want to actually see some work, some effort, and some energy put into addressing my challenge here. Don't just repeat what the papers propose as hypotheses that talk about the Y chromosome dissimilarity. These are untested. This is not empirical. This is a story. Show me a mathematical model. Give me something empirical and show me how a sequence can change extremely rapidly, including these wholesale rearrangements of significant parts. And guys, the evolution of entire gene families. And this has to be done in a very short amount of time, evolutionary speaking. yet stay homogeneous within a species. This is going to be very difficult for them. And so, guys, that is the end of Separate Ancestry Moments 1. And so to recap slightly, guys, the Y chromosome alone, even the mitochondrial DNA, demonstrates the validity of separate ancestry. No, humans are not related to chimpanzees, gorillas, orangutans, dogs, whales, and strawberries. Universal common ancestry has been falsified. We can stay as close to home as possible. We can stay as close to home as possible. And what I mean by that is, rather than looking at what the evolutionary community would say are more distantly related organisms, let's say humans and some kind of plant, banana plants, okay? Because they do believe they're related to banana plants. We can stay as close to home as possible. They believe our closest cousin is the chimpanzee. Okay, let's look at human and chimpanzee, and let's look at their DNA. Genetics is the best way to determine and answer this question of ancestry. A rock, a bone found in the dirt, geography, these things are not inherited sperm and egg. DNA, traits, genetics, that's what's inherited sperm and egg. This is empirical. This is the direct way to answer this important question of ancestry. And the Y chromosome, the mitochondrial DNA, these uniparentally inherited DNA compartments, they demonstrate just how powerful the separate ancestry model is. The Bible claims to be the history book of the universe. In the very first couple chapters of the Bible in Genesis, God tells us that he created two people, Adam and Eve, an independent creation, a special creation that is separate from any other form of life, including your chimpanzees, including your banana plants. And so this data did not have to come about to be what it is. And yet it so amazingly supports the separate ancestry model that comes directly from the account of human origins in the book of Genesis. And so, guys, it is a great time to be a biblical creationist. God bless, and thanks for tuning in.